So this is the drawing quantitative force diagrams 2 problem. And what we have here is an 800 Newton person applying a 600 Newton force to move a 1500 Newton refrigerator, but it does not move. So this right here is our hint that it is at rest, which means that our forces are balanced. All right, and so now we're going to go ahead and draw our interaction diagram. We have the man and the refrigerator. We have the ground, and we have the earth. All right, and so the man is pushing the refrigerator, and the refrigerator is also pushing back on the man. We have the refrigerator standing on the ground, and the ground is pushing back on the refrigerator. And we have the man also standing on the ground and also pushing back. The ground is pushing back. But now what we also see here is that there is some sort of friction, right? So the refrigerator and the ground have some sort of friction, which allows the refrigerator to not move, and so does the man and the ground. So they also have friction. Let me go ahead and label this normal. And then we have everything interacting with the earth. So we have the ground interacting with the earth, and we have the refrigerator interacting, and now we have the man also interacting. Okay, and so then that is our interaction diagram. Now for a force diagram, we see that the man, so this is going to be about the man, right? So we're going to take a look at all of the things that is interacting with the man. And so let's see, let's choose a red color to go around. Okay, so we're going to take a look, and we see that there are, let's see, there's 1, 2, 3, 4 interactions that the man has. Okay, and obviously they have one, that's the force of gravity on the man with the earth. Okay, and then we have the ground that is pushing the refrigerator up. So the man, sorry. So we have the force that is normal on the man from the ground. Okay, and now we are going to look at in what direction is the refrigerator pushing on the man, right? So we're not asking which direction the man is pushing. So we see that the man is pushing in this direction, but the refrigerator is pushing back on him. So we have a normal force on the man from the refrigerator, and our force of friction will be coming from the ground, which will go the opposite way. And we want to make sure that everything is equal to each other, because this is a balanced force. Okay, and so that is for the man. And now for the refrigerator, we have the one that's going into the ground. Oh, sorry, not into the ground, to the earth. And the refrigerator is 1500 newtons. Okay, oh, and I forgot to do this for the person. So let's go back to the man. So we have 800 newtons. And we have a person, so the ground is also going to be pushing up on the man with 800 newtons. Okay, and so we see this from here. And the man is pushing 600 newtons of force in this direction. So this is 600 newtons on the refrigerator. So that means that the refrigerator is pushing back with 600 newtons also. Okay, so this is 600 newtons. So then that means that the force of friction is going to be 600 newtons with the man. All right, so now going back to the refrigerator, We see that the refrigerator also has, let's see if I can do this. All right, so the refrigerator has also 4 interactions, right? So we see one with a man, one with the ground, a friction with the ground, and then the gravitation, the force of gravity. So we have the refrigerator being pushed up by the ground. So with 1,500 newtons of force. And we also have the man pushing the refrigerator to the right. So this is a normal force on the refrigerator from the man, and the man is pushing with 600 newtons of force. So that means that our friction is going to be also 600 newtons of force. All right, and now to identify our Newton's third law pairs. Okay, so we're going to look for the ones with the same feeler-dealer. So we have the same force type. And this is MR, this one is RM. So it's the same players of the feeler-dealer, but it's just like switched. So our feeler-dealer positions are switched. So this would be your N3L pair. All right, and so that is it for this problem.